data. Which brings me to what is the axis of evil in the CMB and how we find it using something called 2003 by Bennett and collaborators, and had maps of the cosmic microwave background in detail like had never been seen before. And a few months later, in 2004, Erickson and collaborators pointed out an unexpected what are as a sum of lots and lots of parts. Leave two, taking the average temperature of parts of the sky separated by 180 degrees. That's the dipole. Then there's the quadrupole with the average of parts of the sky separated by 90 degrees. Then the octopole separated by 45 degrees. Adding all of these together should give you the random distribution that we see in the entire cosmic microwave background. Is that dipole? But what it means is that the cosmic microwave background is slightly hotter in the direction that the Milky Way moves, so it's got a smaller wavelength, and it's colder in the opposite direction, so therefore it's got a longer wavelength. And that's just due to a traditional Doppler shift to the microwave light waves of light, because of one thing we can do is draw an axis through that dipole from the hot spot to the cold spot, and the axis points in the direction of the Milky Way. Is isotropic, i.e. the same in all directions, and homogeneous, i.e. roughly the same except for the quadrupole and the octopole. The axes of these two multipoles are aligned, and this is what's come to be known as the axis of evil, with Land and McGueju in 2005 first using the phrase. So what are some possible explanations for this?
There is no privileged observer of the universe. You and everything about you is ordinary. And this kind of makes sense. If the universe is infinite, how can there be any center at all? The Copernican principle has never been proven, but it coincides well with the cosmological principle, which says that the universe is homogeneous, it's uniformly distributed, and isotropic. It looks the same in every direction. In other words, no matter where you are in the universe, everything is the same. But this is clearly not true. On the smallest scales, such as within our galaxy, we see that star systems cluster towards the center of the Milky Way and along the spiral arms. But on the very largest scales, like cosmic web, this is widely accepted to be true. The best evidence for the cosmological principle comes from measurements of the cosmic microwave background. When you look up at the sky, you'll see that most of space is empty, apart from the few stars and galaxies here and there. Well, at least this is the case in visible wavelengths. When instead we observe the sky through microwave wavelengths, the sky is bright. It's filled with a remnant radiation from events in the early universe. This is the cosmic microwave background, or CMB. Homogeneity and isotropy is evident when you remove the plane of our galaxy, the Milky Way. The CMB is 2.73 Kelvin in temperature everywhere. It's also one of the best evidences that we have for the theory of the Big Bang. Since the CMB is the same everywhere, all parts of the sky must have been causally connected at some point. Otherwise, it would be very strange that two regions separated by more than the age of the universe have exactly the same temperature. This in turn leads to the conclusion that the whole universe appeared at a single moment in time. However, with better telescopes and higher resolution, it seems that there's a number of claims of evidence for a preferred direction in the universe. Does this mean that there's an anisotropy? To measure the anisotropy of the CMB, astronomers use what is known as multipole expansion. They look at ever smaller scales on the sky for any signs of variations. The first pole, the monopole, looks at variations in CMB temperature on the entire sky. The second pole, the dipole, essentially splits the sky in half and looks for anisotropy there. And then the quadrupole splits the sky in quarters, etc., etc. And you're getting to smaller and smaller splits on the sky. The point is that if the universe is truly isotropic, then you expect that for all of the poles to have different directions. Regardless of the split, they should be completely random. And initially, that seemed to be the case, except when you look more closely at the quadrupole and octopole. On these two scales, the multipoles appear to point in almost the same direction. And whilst this was first dismissed as statistically insignificant, better data and independent analyses means that it is now a real concern. From the dipole, it would appear that half of the sky is slightly cooler than the other half, and this is perfectly divided by the quadrupole and octopole axes. This anomaly in the CMB is known as the axis of evil. But here is where things get a bit weirder. The axes also perfectly align with our ecliptic plane, and this suggests that our solar system, and hence also the location of the Earth, is significant. Is this just a coincidence, or is it an evidence for the departure from the Copernican principle? If we can rule out systematics, a deviation from the Copernican principle could have big consequences on physics as we know it. Currently, our standard model of cosmology, lambda CDM, relies on the assumption of a homogeneous and isotropic universe. But if the Copernican principle doesn't hold, then
we are made of matter, which means we experience time. But what if we weren't made of matter? What if we were made of something timeless, like light instead? What would the universe be like for us? Okay, so stuff in the universe generally falls into two major categories: matter and light. What separates them is their rest mass. Matter has it, light doesn't. But categorizing things by their mass can be problematic, because mass is not a fundamental property, it's an emergent property. It appears out of the interactions between particles, out of the ensemble. Seriously, consider something extreme like a black hole. You've probably heard of black holes eating entire stars. But they don't just eat matter, they also eat light. Light is massless, but if a black hole eats some, it'll still grow. The light has become massive just because it's trapped. We call it confinement. Mass emerges from that confinement. For that matter, you don't even need the black hole to begin with. If you get enough light in one place, it'll become a black hole all by itself. It's called a Kugelblitz, a ball of light.